Hello, everybody, and welcome in. We are so excited that you have joined us today for an awesome weekly demo. At this point, I'm just going to give everybody a few minutes to filter in and get situated. You can grab some coffee, some water, whatever you're in the mood for, and then I'll come back on in just about 2 minutes to get us hot and ready. But until then, just settle in and just going to give everybody a few moments to filter in. Thanks for your patience. If you are just coming into the meeting, we're just going to give everybody about 1 more minute to filter in and get situated. Thank you so much for your patience. Alrighty, looks like we are ready to get started. Again, thank you so much for joining today. We are so excited that you are here for our weekly demo. And at this point, I am going to turn it over to Ken Towne.
Thank you so much. Thanks everybody for joining today. I want to talk about how anybody is able to use our scenarios, and by making some minor customizations, you can use them to exploit any of these web-based vulnerabilities. We're going to use Text4Shell as the example for today's demo, but this can really be applied to any web-based vulnerability, Log4Shell, proxy not shell, whatever. We'll start with just a very quick introduction. My name is Ken. I'm the technical lead on the Adversary research engineering team here at AttackIQ. Been at AttackIQ for just over a year. I'm primarily focused on threat research, malware analysis, and attack graph design. But first, before I talk about Text4Shell and how you can use our platform to validate your security controls, I want to talk a little bit about a subject that's sort of contrary to what the original intent of this demo is. This is a graph taken from cvdetails.com of the vulnerabilities that are being discovered every year for the last 10 years. And you can see that the numbers are just insane as you get into the last 2 years. So far, we're sitting at 22,000 plus vulnerabilities, and shaded in blue are the criticals. So I think for this year, it's somewhere around 850, 860 critical. These are CVS score 9 and higher vulnerabilities. So these things aren't going away anytime. And the media is obsessed with them. You see all the stuff for Log4Shell when it came out, the world was ending. Then there was Spring4Shell, the world was ending. Proxy shell, proxy not shell, world is ending. Text4Shell, all of these vulnerabilities continue to pop up, and they're not going anywhere. And so while yes, you can test your security controls around these individual web vulnerabilities, that's probably not the best use of your time. You really want to focus in on a couple of things. If we take a look at the traditional iceberg meme, there's the initial access side of an actor. This is where I would group up all of your exploitation, but then there's everything else that they do. All of the behaviors that they're going to do beyond those initial dropping the web shells, those end up being pretty consistent. So they're doing the same kind of who am I commands and dropping web shells and doing system discovery and network discovery, no matter which vulnerability ultimately they've compromised you with. And so what should you be doing before you're really going to narrow in and focus on maybe testing one specific vulnerability? You really have to have a software and library inventory management system. It's one thing to know what software you're running, but where Text4Shell comes in, and this is similar with Log4Shell, it's actually a component of many other software libraries. And so if you don't know what's making up the software that you're running, there could be vulnerabilities for things that you didn't even know that you have. And then obviously the only real way to stop a vulnerability and the exploit of that is to do vulnerability and patching management. Patching is your only way to stop them from being able to exploit that vulnerability. Vulnerabilities evolve over time. You saw with Log4Shell, they were coming up with different ways to format those strings, and those were getting past all of the security controls. And if you were vulnerable, you were still getting exploited. And then finally, validating all of your defense and depth controls, the whole bottom of that iceberg. You know, if you have a web server and you're only focused in on the traffic that's being sent to it, you're going to miss whatever the next 0 day is. That's the point of a 0 day, is nobody knows about it, nobody has control in place to prevent it. And so what you want to be looking for is that system doing all of the weird things that it would not normally do unless there was an actor on there probing around. But enough about that. Let's get into Text4Shell. So what is Text4Shell? If you're not familiar, Text4Shell is a vulnerability in the Apache Commons library. The Apache Commons library is a project from Apache, and they're focused on making reusable Java components to make Java web development or any kind of Java development easier and more consistent. And inside of Apache Commons, they have a library called the Commons Text Library. This is a really cool library. It does a lot of really helpful things for users that may adopt this into their program. But the one that becomes an issue is string substitution. So this is a very plain, simple, at the bottom here, use of this library where they can expand out what the Java version that's running and what the OS version that's running. And so these add some dynamic ability to your web page of what it might print and display, or a console application of getting environmental variables or any kind of variables to help format print them into those strings. And they offer a ton of additional functionality that makes working with those strings easier. So decoding base64 data, manipulating dates, getting files, messing with Java, decoding URLs, looking at XML, all these things make it easier so you're not having to write your own library. However, there are 3 additional lookups, and they're not included by default. And this is one of the reasons why Text4Shell ended up not being one of the larger problems like Log4Shell, is these lookups are not enabled, but they offer some support that gather external resources or essentially allow for full code execution. So the DNS one, what this is going to do is it forces that system to do a domain lookup. It's going to resolve that domain to an IP address. This is great to use for canary domains. So a canary domain, you monitor all DNS requests, and if you see a DNS request for your special domain, you know that they're vulnerable and you can be alerted to it. So you can use the DNS address lookup to look up your domain and find out who might be vulnerable. The URL, this will actually retrieve from the remote address that you provide all of the contents. Now, depending on how that application is written, maybe this prints all of it out to the user. This would be great for cross-site scripting where you're doing phishing and you can essentially pretend to host files on a legitimate site. But probably the worst of all 3 is the script. And this allows you to actually execute JavaScript code, any JavaScript code that you want. And Java has the ability to actually run commands at the OS level by calling the Java lang runtime, get runtime exec. So I can write to files, I can copy files. This is what they're using to actually write web shells to disk, at which point they can now do whatever they want. You could also ransomware a system, you could kick off crypto mining commands, you can do anything you want with this combination of string lookups. And so when we go back and we look at these strings, they're very simple. They're very easy to understand. It doesn't seem hard at all. I can easily put in a command, and that is recognized in the score, the CVS score. This one gets rated as a 9.8 because it's network accessible, so you can exploit it remotely. It's not complex whatsoever to actually exploit. You saw what those strings look like. You don't require any privileges. A lot of sites that might use this, you don't even have to be logged in. If you just know what component is vulnerable, it's easy to do. And it requires no user interaction. So nobody's clicking, nobody's having to do anything. You can just fire away your your exploit, and then you're immediately running code. And so the score is extremely high. Now you might be thinking, okay, this is like having a golden key. It's super easy. Any site that has it, the Apache Commons library is used everywhere, but that's where it's not as simple as you might think. On those pages, because this is a library, it's up to the designer of that application to say where and when they're going to use any of those string formatters, and they would also have to have enabled those three lookups, any one of those three lookups. Now, just because you are running Apache Commons library, you have vulnerable components, but unless you're exposing those and you're offering a way through your website to interact with them with user provided data, the exploitation is just not there. And so I don't have a base request that I can make with like Log4Shell or some of these other vulnerabilities where it's a vulnerability in the larger application, not the library. So I can't just pick one and go, all right, hey, I'm easily into this system. I have to search and know specifically which field, which page, which site will allow me to get through. So what are the options as far as like validating controls when this first went live in public? Well, the first thing that people were doing is they were seeing, okay, well, actors are trying the following things, or in my demo environment, I was able to get it to exploit this way. And so a lot of things were being passed along, specifically around this search. So if you pass this value to the search variable, you can, run the Java runtime. But if your site doesn't have search, this isn't going to work. And the same thing if you're using like the URL prefix. These were like WordPress comments. People were trying to exploit this way. If your site doesn't use these URIs, doesn't take advantage of any of these values, and more importantly, doesn't actually forward this to any of the string lookups, well, then none of these examples that people were providing on Twitter or in GitLab gists are going to be of help to you. And you're going to get that false sense of security because you will run these exact same commands, you won't see anything bad happening, and assume that you're safe. And so what's a more advanced version of that? Well, these people at Silent Signal, they released a really cool burp proxy plugin. And what this will do is it will find all insertion points in a web page that you go to. So an insertion point could be a search box, it could be an input box, it could be any kind of values that are being passed. And then it's going to flood every single one of those insertion points with the Text4Shell strings. And so if one of your sites that you're spidering out through just so happens to have that publicly available, maybe you'll find it. However, you're now starting to trigger things like brute force detection and people that are doing scanning. And so this isn't necessarily a test of a single control, but your brute force controls, your DDoS controls of trying to stop this. And again, this will only work for what's available that you're allowing the burp proxy to get out and touch. So if you have things gated behind a login page or a hidden admin page that maybe isn't linked here, but a targeted threat actor would be able to know about, this isn't, again, going to turn up that vulnerability for you and test whatever controls you have in place. And so what is the only real way to understand and test out when it is a library? Well, you actually need to understand your code. And so on the left here is the source code for one of the proof of concept vulnerable Spring applications that are out there. And so we can see in the middle, they're using a string substituter where they call the replace function, and this will trigger the vulnerability. And so if this was written into my own code, I would need to be searching through and understanding my own code's usage of the Apache Commons library to even know where to begin. And then now that I know where to begin and what specifically how I need to format it, now I can actually kick off a validation and see if my controls are really in place. So now that you understand that you have to know the nitty gritty of how your application works, where you're putting the vulnerability, let's talk about how you can use our web request communication scenario to actually exploit these and check the controls and if they're working or not. So we have a base scenario that we call the web request communication scenario. And just like all of our scenarios, the source code is fully available to all customers, and it comes with a ton of configurable parameters. The gist of this scenario is that you configure a web request. You provide the URL, what protocol, the domain it's going to, the path, is it a GET or a POST? Do you have query strings? Are you providing POST variables? Are there headers? Everything about the web request you have control over, and we can use these parameters to mold them into exploiting Text4Shell. So let's talk about the lab that I'm using for this demo. I have two web assets. So my AttackIQ agent is running on a system inside my network, and this system in my network has access to these two web applications. One is unprotected, so the web application, which is is a modified version of a proof of concept from GitHub, and the only control in place here are the hopes and dreams. So I don't actually have any security controls. I just hope that an actor won't find my page, hope that they won't know how to exploit this vulnerability, and maybe, just maybe, I'll be all right. You're not going to be all right. So on the protected side of things, I have Suricata in place. And so Suricata, you can feed it different rules for your intrusion protection system. And we have some rules that were published with Proof Points Emerging Threats rule set that is supposed to cover Text4Shell. So all three of the string substitution methods, the DNS, the URL, and the script, they do have signatures for. And so we've loaded up those signatures, we've put our Suricata inline so that all web requests will be inspected by it and they can drop that activity. The vulnerable code. So in the app, what we're looking for and what I have highlighted in red is the vulnerable parts of this application. And by reading the code, our first line is saying what endpoint is being used. In this case, it's the /message endpoint, and that this request is going to be a GET, and we're looking for a parameter being passed along called text. Okay, and what this code does is it takes the value that the user provides for text and it runs it through the interpolator and the replace function. The replace function is a part of the string substitutor, and any of those special strings will be replaced by the program. And so what does this look like for the URL? Okay, so I know in order to exploit this application that's running, this is the format that I would have to use. This isn't the /search that we saw with some of the original examples that were being posted. This isn't the /post that was being done for the WordPress comments. This is our own application. And again, this is a modified version of the proof of concept. So this is specific to me and how I implemented, similar to if you were using this library and you were putting it into your own web application. It's up to you to decide how it's being used. So we know we need to do message, pass the text value, and then that's where our vulnerable string is going to come into play. So let's go back to the rules for Suricata. So this is one of the rules that they published looking for the DNS prefix. And so if you can't read hex, I'll break it out for you. But this is looking for any inbound web requests, and it's going to examine the URI. So that's the full end of the URL. And what it's looking for is hex value 3D247B, which is equals $, and then your left curly bracket, and then DNS, : address, and then the pipe symbol. And then this is where you're going to then have whatever address is going to be looked up. And then it's looking for a match of the closing curly bracket after that first match has been found. So what this really looks like is DNS address and then the domain that you want. And so we know that in order to exploit my specific web application, this is the web request that I need to make. I need to go to my domain, to the message endpoint, and for the text variable, pass in the DNS address in this format. So let's go do a live demo. So the first thing I'm going to do is I have an assessment pre-staged. So an assessment in AttackIQ is a way to chain up multiple scenarios, one or many, and I have them broken down into 3 separate tests. I have a test against my unprotected asset, a test against my protected asset, and then another one I'm going to call trust but verify, and I'll go into a little bit more detail later. So let's look at the scenarios that are assigned to this specific test. So I'll click on the dots, go into manage scenarios, and I've selected my web request communication. The dots again will allow me to go to the configuration, and this brings me up to that parameters page that we talked about on one of the slides earlier. In this setup today, I have HTTP, so that's our protocol. I'm not using HTTPS. You can if that's what your server supports. For a lot of the command and control testing that we have a AttackIQ domain that you can use, but in this case, we want to test our own infrastructure. And so I've provided the IP address and port that I'm going to be using for my staged up web server. This is obviously a local IP, but you can put any external domain, any external IP. The only requirement is that the agent that is running this test needs to have access to it. The path, so we know, is /message. It's a GET request, and then our query string. Now our query string looks a little different than what we saw on the previous slides, and that's because we have to URL encode them. So all I've done is take my DNS address, and I'm going to do a lookup of attackiq.com, and I've run it through a URL encode. And so it's converting those non-standard URL characters into essentially their hex URL version. So %24 for the $sign. And then we can take this value and we can put that inside the scenario. So that's our query string. Now, if I needed to make this a post, this is where I would assign post values, or I could put full post data, but in this case, it's just a GET request similar to like a search. Now, if I needed to add any special headers, whether it's authorization, my user agent, additional values, cookies, things I want to add, I have that option, and you can actually exploit Text4Shell this way if your server is trying to expand out those values. But in this case, I don't have anything to add. The last thing that you need to configure is how do you tell whether or not this scenario was successfully able to execute the attacker's intent, or was it prevented? And so we have a couple of options. You can match the response status code. So in this case, we do have it checked and we're looking for an HTTP 200 code. What this means is my request was accepted by the server and I got a response back. I can also match the response expression. So the data that gets returned by the website, I can look for certain strings inside of that, and that will let me know if everything was okay. Depending on what your security control that you have, maybe your blocked pages have a specific string that you want to look for. Maybe the real page that would get displayed would have something there too. And so you can put in what you want to find. And the way that this will work is when it runs, it'll try to make the request. It's first going to validate the status code. Did I get a 200? And if I did, and this value is checked, I now need to check the content to try and find that match. If those things are all there, then I will say that my attack was successful. The actor was able to successfully do what they wanted. No controls prevented me from making this request. I got back exactly what I thought I would. Now, if the resource is unreachable, this means you don't get a response because the domain can't be looked up or the thing never responds or the timeout occurs. You can say that this is either protected or succeeded. So these depend on what your use case is. In our case, we have Suricata in line on the protected assets and it's going to drop those packets. So to me, if a resource is unreachable or the timeout occurs, then the attack is prevented. Okay. Now I'm going to look at the protected asset. So I'm going to go into the scenarios for that test. And the only difference is I'm pointing at a different box. So the previous one was .128 and this is .129. Same thing, /message, same application, get, same query string, same validation, matching the response code, the 200s. I'm not going to go into the configuration of trust but verify yet because I want to show that at the end, but it is essentially doing something very similar. I pick the asset that I want to run. So this is the host that I'm currently running and it has access to both of these local boxes. And then I'm going to go to the on-demand page. Now you can schedule these assessments to be run on a regular basis, so every day, once a week, or on demand. And in this case, I'm going to run it right now. So right now, I just go ahead and click Run Now. This is going to tell you, hey, we're going to run this assessment. And it kicks off. And what's going on behind the scenes is my asset with the agent is going to receive the request from AttackIQ. It's going to tell me, hey, I've got 3 tests that I want, and these tests are made up these scenarios. It will go through and run each of those scenarios and then report back on whether or not it was able to reach the page. This will take a few minutes to run, so I've pre-generated earlier before this demo some of the results. And in the results, we're going to see not prevented on our unprotected asset, prevented on our protected asset, and then on this third mystery one, not prevented. So let's click into the details. And so if I click in the first one, I can see that in my findings, the connection from my host to this specific URL was successful and given the phase parameters. And the activity details give me the raw logs. So in this case, we're only checking for the 200 code, and it passed. So when it made the request, it didn't receive any errors, didn't get a 400 code, it got a 200, and therefore we consider this attack successful. If I go to the next machine, which is my protected asset, I get a prevented. And so when it tried to make this request, the request timed out. It waited 90 seconds, tried to get there, but it never responded. And this is likely because Suricata stepped in and prevented that activity. And we can see what the request was, message here. And then our final one is to that same asset that has the .129, so it has Suricata, but this one was successful. And the only thing different is the value that got passed. And so I want to show you from a command line I'm going to make a curl request first to my unprotected asset. This is the exact same URL that got generated with our web request communication scenario. And when I run it, I immediately get a result back. So I told it to do a DNS lookup of attackiq.com. And when it made a request out, it got this IP address back. So it prints out the response. If I try to do the same on my protected asset, which is the .129, I've set a max time of 5 seconds. Otherwise, curl will wait a minute. And I just want to get a result back quickly for the point of this demo. But we'll run that, and I don't get anything back. My timeout occurs. Now, one of the problems with vulnerabilities is that they do evolve over time, and the reporting that's out there isn't always going to be fully accurate, and the signatures that you get from vendors isn't going to be fully accurate. If we go back and we take a look at what the signature is looking for, they're looking for DNS:/address pipe. You don't actually need the address pipe. The way that the Java Common Library, Apache Common Library works is it just looks for DNS whatever, and then we'll look it up. And so if I configured my request to ignore the address part, so I'm going to get rid of the address pipe, and I run this, I immediately get a response back. So, here I am thinking that I have all of the controls in place, that I know exactly how this is supposed to work, but these things still fail. If we go back, I think our results are probably ready at this point. So here are the live version. So you can always check the status by doing the drop down. We can see that there are no more scenarios to be run. So I can click into the live results, and our live results match exactly what we got from my earlier demo. So the initial request was not prevented. The one to the protected asset prevented, and my trust but verify not prevented. Okay, so some final takeaways. 22,796 vulnerabilities discovered just this year and counting. So that number was taken from this morning. I imagine if I go to the CV details site, there'll probably be 1 or 2 new ones. It's an absurd amount that are being reported every single day. And next year is going to be worse. We saw with the graph, the counts are going up higher. There's not going to be less vulnerabilities discovered next year. More researchers, more actors, more everything are turning these things up, and we'll continue to have the same kind of media craziness that we saw with Log4Shell and Text4Shell every time these come up. And what you can see here is that vulnerabilities are complex. When you get into it being a library, it adds a whole new layer of complexity where it's not a base website, there's not a standard URL, there's not a standard anything that you can access and go, hey, I'm good. There's no scanner that I can immediately download. There's nothing that I can do on my own that's quickly going to tell me from an external point of view whether or not I'm vulnerable, right? I need to have that asset inventory and library inventory to even know what's there. And then once I know it's even there, I need to understand its configuration. I need to understand where it's set up in my app, how all of that works, and where could I possibly be vulnerable to that specific exploit. Log4Shell was very simple. Text4Shell, very simple. Thankfully, because of that simplicity, it's easy for you to go and see what's there, but other exploits aren't always so easy to go, oh, it's just this magic string. It's certain bytes in a certain order with timing, and you have to do NOP/sleds and things like that. That becomes a lot harder to emulate and test. And so since vulnerabilities are complex, the validation and exploitation of those controls is also complex. So we saw all of the things that I needed to research and find to configure those scenarios correctly, the way that I need to format those strings, and where exactly I'm sending it takes a lot of time. Initial access, it's always evolving. So 22,796 vulnerabilities, how many of those are for initial access? You got phishing, web vulnerabilities, bad USB drives, you name it. The way that actors are getting in evolves and changes every single day, and an actor is not going to exclusively pick just one way. A targeted actor has 100 different ways to try and get in, and therefore my recommendation is to always assume there's a breach. Don't just trust those external controls at the very end, your firewalls, your WAFs, your email filters. They're going to fail. There's going to be a vulnerability in them. An actor is going to get past it. You really need to understand and do defense in depth. So there is a much greater effect by prioritizing that deeper part of the iceberg. That wasn't covered in this webinar, but if you go back through our page, you'll find a lot more in our blog and our YouTube channel where we really talk about how you actually should be emulating actor behaviors, ignoring what the initial access is, assuming the breach, start post-compromise. because while there are hundreds of different ways for them to get in, there's a lot less for them to actually find what they want and take control and achieve their goals. They're going to use the same native commands to discover your network and move laterally. There's only so many ways for you to set up persistence on a Windows host, and same thing on your command and control and your backdoors. Whether you're going ransomware or exfiltration, they're going to exfil. They still need to get the data out. There's a lot less and a lot more opportunities that you can find actors and stop them if you move on and put a lot more resources on that deeper part of the iceberg. And then most importantly, continuous validation. So trust but verify. Don't just believe that your security controls are working. Make sure that they're working. If you're always ingesting the emerging threat rules, you will have pulled in these rules, but the rules aren't perfect, right? So you still need to understand what your real threat is. That's all I have for today. So unless there are any questions, I'll go ahead and turn it back over.
Awesome. Thank you so much, Ken. If anybody has any questions, you can pop them in the little question chat box below. I'm not seeing anything, but maybe we can just wait a minute to see if anybody wants to pop one in there. And if not, you can always reach out to us at AttackIQ or reach out to Ken personally. His email is on the screen right now. Not seeing anything pop up at the moment, so thank you so much, everybody, for joining today. We look forward to seeing you again on a weekly demo real soon. Have a wonderful day.